Remote Sensing 2, an introduction. The main problem here, when you start looking through this, the main problem is sampling design, and we know this. This is what causes, the unevenness in data collection when you're trying to collect it on the ground, because it's hard to get, randomly to every place on the ground. Roads don't do that for us, and so remote sensing somewhat solves that problem by pretty much completely randomizing data collection. In other words, collecting data, sampling at a very high resolution for over very large areas. So it goes a long ways towards solving that first problem. The other problems are problems, but they're nothing like that first problem. And we know pretty much what a remote sensing instrument is, and we're usually concerned with the instantaneous field of view, which determines in most instruments what the size of a pixel is. So usually when we're talking about the IFOV, we're talking about the pixel size, which ultimately gets represented as a square or a rectangular raster. And remote sensing, it's a science technology, or it's a technoscience. It's linked to a particular technology and set of techniques, and so it is a big part of science. Whether it is a science or not, well, I don't know. Something to think about, though. So this is the full process is represented by our text author, and in fact, we're mostly concerned with these parts of the process here in this class. Certainly, it is a big process, but ultimately, we do want to get to a place where we are, finishing up our program and making things that are useful to ourselves and to others who work in the same area that we work within. So normally we're looking at radiance. We're looking at the reflected radiance from different parts of the Earth, very small parts of the Earth, usually from within a pixel, is probably the most common unit that we use. Excuse me. And so, if you look at this, the radiance that we look at is dependent on a number of different factors, but probably most importantly on the wavelength that is selectively reflected, and also the energy that's available from that wavelength. Longer wave radiation has less energy. Shorter wave radiation has more energy. So right down to practically into the ultraviolet and way out into the infrared, that's the case. And so, when you're looking at spectral resolution, we really are thinking about systems now that can collect data continuously in hundreds or even thousands of channels. We're learning mostly on multispectral systems that use discrete channels that are separated one from the other, discretely bounded channels in the spectral continuum. And so, things do change in this sense, and there is quite a bit of variability between sensors in terms of spectral resolution. So this is something we always have to be concerned with. Spatial resolution, of course, is something we're always concerned with, and you guys know all about that. And temporal resolution, particularly when you're doing change analysis, this is an important aspect of our work, seeing how frequently imagery is repeated, how repeatable it is, what are the conditions that determine that repeatability, and radiometric resolution. Again, what is the depth or the number of possible values that we can sense or quantize the measurements that we're making into. So most of the data that we've worked with so far has been 8-bit data, but we're starting to work more and more with 10, 12-bit data, and so you're going to see more and more of that, where you don't have the 0 to 255, but you may have the 0 to thousands of possible values. So, remote sensing also has a number of angular characteristics to it, and in particular, this comes from the location of the pixel that we're looking at in relation to the sensor, whether it's directly beneath the sensor or out, to the side or in front or in back of the sensor as it travels in its path. The orientation of the terrain facet, its slope, if it is angled in one direction or another, and also the location of certainly of the sensor in orbit. And so this is always part of what we do. And then these are just some examples that we used at the end of this to illustrate some of the kinds of data that we hope to be working with this term.